Hello, everybody. My name is Mr. Kelvin from Educare Tanzania. Welcome again into our lecture session. And today we are going to look physics, and our level is Form 3. Within physics Form 3, we will discuss our topic known as light. Within light, it have many subtopics. Among of them include reflection of light from a curved mirror. Not only that, subtopic number 2 is refraction of light, which is bending of light, but also there is refraction of light through a rectangular prism, but also a refraction of light by triangular prism. But also there is colors of light, and finally there is refraction of light by lens. So today we are going to discuss subtopic number 6, which is the refraction of light by lens. Within this subtopic, there are some of the concepts which is being covered within this subtopic. Among of them is to distinguish between convex and the concave lens. So within this topic, we learn how we can distinguish between concave lens and a convex lens, but also we try to explain some terms like focal length, principal focus, principal axis, optical center, as they applied to a lens. But also we learn how we can determine the focal length of a lens, but also how we can locate the image by using a ray diagram, but also how we can determine the size, position, and the nature of the image formed, and also to determine the magnification of the lens. So today, basically, we will spend much our time dealing with issues of magnification and some sort of things, including position, size, natures of image formed by lens, but also how we can determine the relationship between a focal length, object distance, together with image distance. So without wasting our time, let's start looking about linear magnification. When we say magnification is a measure of the extent to which an optical system enlarges or reduces an image in relation to object, kwamba tunapozungumzia magnification tunazungumzia ni kwa kiwango kipi hizi optical system au optical device ambapo tunazungumzia lens imeweza kuenlarge. Kuenlarge ni kama kukuza, au to reduce ni kama kupunguza ile size image ambayo ina correspond to object. That is a magnification. So mathematically magnification tunaweza tukasema kwamba when someone trying to find magnification, he can take image 8 then akadivide by object 8. So when you take image 8 divide by object 8, unaweza kupata magnification. So we say that IH inamaanisha nini? Inamaanisha ni image 8, but OH means object 8, but M manake ni magnification. So this formula can help you to find if an object, its image is being enlarged or is being reduced. So you can use this formula by taking image 8, then you divide by object 8. But also there is another formula which can be used to find the magnification of image. So you can take magnification is equal to V over U. V inamaanisha nini? V maana yake ni image distance and U maana yake ni object distance, where V is the distance of the image from the lens. So the distance of image from the lens is what we call v. But also u means a distance of object from the lens, and m stand for magnification. Hivyo ndivyo jinsi unavyoweza kucalculate magnification ya image yako. How, to which extent can optical system either enlarge or reduce the image corresponding to object. Okay, also there is another thing called the lens formula. So the lens formula, it is being given by taking 1 over focal length is equal to 1 over object distance plus 1 over image distance. So ukichukua moja chini ya f sawa sana moja chini ya u ukijumlisha na moja chini ya v. Hiyo ni formula ambayo tunaita ni lens formula, but ukiangalia ni sawa na mirror formula. So using this formula you can determine the focal length of the optical device, but also you can determine the wavelength focal length of your lens. But also u means which to what distance the object stands from the lens. Means we talk about the object distance from the lens. But also v means in which distance or to what distance an image stands from the lens. Okay, there is something we call real is positive conversion. So real is a positive conversion. We say that to calculate the value of object distance and image distance, a sign rule or conversion is adopted. Kwamba tunapokuwa tunatafuta either ni object distance au ni image distance, we adapt the sign rule or conversion rules. So the rules is referred to as a real is positive conversion. Kwa hiyo sheria ambayo tunakuwa tunaiadopti au tunakuwa tunaifuata inaitwa real is positive conversion, na tutaiangalia hapo mbele ni kwa namna ipi hii sheria jinsi ilivyo. So this is sign for object and image. So for real image we say that image distance must be positive, but also object distance must be positive. These are the formulas when the image formed is real. We use v is equal to positive, but also object distance will be positive. Let's look when the image formed is visual. Tulishasema image formed ikiwa ni real inakuwaje na ikiwa ni visual inakuwaje. So sign for visual object and image. When we talk about visual object and image, we say that v is equal to negative, means image distance is equal to negative, but also u ambayo ina stand for object distance will be equal to what we say negative. So for visual image and object, v, which is image distance, is equal to negative, but also u, which is object distance, is equal to negative. So something to note, we say that sign of visual object and image is negative. Why it is negative? The reason is here, because the principal focus of a concave lens is visual. Because the principal focus of a concave lens is visual. That's why image distance and object distance are negative in sign. So if you are being asked why there is negative sign and negative sign for object distance and image distance for visual image in a lens, say that this is because the principal focus of a concave lens is a visual. Okay, number 2, we say concave lens are the positive value of a focal length. So convex lens yoyote ina positive value ya focal length. As you can see, focal length is sawa sana positive, but concave lenses have negative value of a focal length. So if you are being given a concave lens, its focal length is negative. Okay, something we say that image formed by thin lens. Let's look the image formed by thin lens. We say that let us look image formed by convex lens and a concave lens, kwamba tuangalie image inayokuwa inatengenezwa na hizi convex lens and concave lens zinakuwaje. Tunasema kuwa tuanze na image formed by convex lens, kwamba image formed by convex lens inakuwaje. We say that object at infinity. Tukitaka kuangalia image formed by a convex lens, lazima tuangalie katika pointi tofauti tofauti, kwa sababu tukiangalia katika point tofauti tofauti ndio tutaweza kudetermine the nature, position na size ya image inayokuwa formed. So tukianza na position ya kwanza ambayo ni object at infinity. When you place your object at infinity, we say very far from the lens. Its diagram can be look like that, kwamba hii ni object ipo katika infinity, na tulisema kwamba ray inayotoka katika object ina be reflected inapokuwa imepita katika lens, ina be reflected kupitia principal focus kama inavyoonekana hapa. Baada ya hapo zinapita rays zinazofuata zinapita katika point ambayo ni optical center. Zikipita katika optical center zina reflect kupitia optical center, so image itakuwa imetengenezwa hapa. So tuone its properties, kwamba properties formed by image ambayo inakuwa katika infinity. The image formed, it is real. Why it is real? Inakuwa ni on the same side na object yako. Also formed at principal focus, formed at F, but it is inverted. Inverted we say it is upside down, kwamba inakuwa imegeuka, kwamba ukiwa na object imesimama inaangalia juu lakini image yake inaangalia chini. That's why you say upside down. But also diminished. Diminished means smaller in size than object, kwamba object ni kubwa kuliko image iliyotengenezwa. That is image at infinity. Tuangalie property nyingine ni object at center of curvature divided by 2f kama inavyoonekana hapa. So at 2f kwamba inakuwaje? So we say diagram is looking like that. Tulisema ray inayotoka katika object inaenda mpaka katika mirror au lens. After that ina reflect kwa kupitia principal focus. After that una draw line ili upate image inayopita, upate image, na hiyo line unayokuona i draw inapita katika what we call optical center. Unapopita katika optical center zikikutana zina join hapa, na hapo unaweza kupata image yako. So what are the properties? We say that properties of image formed. Property number 1, it is real. Number 2, formed at F. It is inverted upside down, same size as the object, kwamba inakuwa na same size as object. So tuangalie kitu kingine, object beyond C/2f. So beyond means ni nyuma ya E point kama inavyoonekana hapa. The same procedure ya kudraw ray diagram, kwamba utadraw object then ray inatoka hapa mpaka kwenye lens. After lens ina reflect kwa kupitia principal focus. After that una draw line inayopita katika optical center ili upate image, na tulisema line inayopita katika optical center ina reflect kwa kupitia hiyo optical center, so image will be formed at that point. So tuangalie properties of image formed. We say that image formed will be real, also formed between F and C/2, as you can see ipo katikati ya 2F na C. Also it is inverted. Also magnification is larger. So vyote hivyo tumeona katika previous slide. Okay. Tuangalie property nyingine ya object at F. Object katika principal focus. Diagram yake inakuwa kama hivi. So at this point, if we want to find image, inakuwa kama hivyo. So as you can see, this image itatokea katika infinity. Property zake tunasema property of image formed. Number one, it is real but also formed at infinity. It is inverted means upside down, but also magnified means larger in size than object. Also object between F and the lens. Object ipo between principal focus na lens kama inavyoonekana hapa. So image formed inatokea on the same side na object yako. Tuangalie property. The image formed is visual, not real, but behind the object means imetokea behind the object, nyuma ya object yako. Also erect. Erect means iko ni upright, but also magnified, larger in size than object. So those are the properties of image formed katika point ya F and lens. So let's look image formed in a concave mirror, in a concave lens. Ile ilikuwa ni image formed katika convex lens. So we say that the image formed are always visual, ni erect and diminished for all object position. Kwamba katika concave lens, the image formed are always visual. They are always erect. They are always diminished for all the position you put your object. As you can see the diagram, so kama unavyoona image itatokea katika hii point, as you can see. So that is how you can draw the image formed katika concave lens. What are the properties of image formed? We say that property number one, it is visual. Tumeshaona kwamba image formed katika concave lens ni visual, formed between the object and the lens. It is being formed between the object and the lens, but also it is erect, means it is upright. Diminished means smaller in size than the object, but also image distance, as you increase to infinity, also v increase to focal point. Kwamba kadri unavyoongeza object distance to infinity, also image distance inaongezeka to focal length. Okay, that is today's lesson, and before we close our lesson, let's have an exercise to perform. The question is, what is linear magnification? So as we learn now, you can define what is linear magnification, but also you can explain properties of image formed in a convex lens but also in a concave lens. Kama tulivyosoma, sasa hivi unaweza kuelezea properties za image formed katika concave lens na katika convex lens. And by saying so, this makes the end of our lesson today. Welcome to the coming lesson. Goodbye.